Hi, everybody. We're going to be talking to you today about Houdini and the future of the web. Yeah. So before we start, you probably want to know who we are.
Hi, I'm Ian. I work out of the Mountain View office.
Hi, I'm Eddy. I can't figure out how to turn my microphone on, but I work out of the Sydney office.
And I'm Shane. I also work out of the Sydney office. Between the three of us, we're responsible for pretty much most or all of the implementation work that's going on inside Chrome for Houdini. And we also do a lot of the spec work, or at least Chrome's portion of the spec work. There's a few more details on the slide. So I'm going to try and tell you what Houdini is. And to tell you what Houdini is, I'm going to start with the Extensible Web Manifesto. Everyone's heard of the Extensible Web Manifesto? Yes? Anyone hasn't heard of the Extensible Web Manifesto? So this is a document that was put together by a bunch of pretty important spec wonks and other people. And the idea of it was to say, you know what, we've got to stop building all of these high-level tower APIs. We need to concentrate on the basics. We need to concentrate on providing low-level APIs that you can build the high-level APIs on top of. I think this is a very good quote from the manifesto. To enable libraries to do more, browser vendors should provide new low-level capabilities that expose the possibilities of the underlying platform as closely as possible. So Houdini is the extensible web applied to CSS. Some things that you can do with Houdini: you can build new CSS primitives without waiting for a specification committee to spec them for you. You can achieve better interop faster, because these low-level primitives are much easier to test and much easier to make interoperable than large, high-level features. And you can scratch that itch. You can take a feature that somebody else has built using Houdini, and you can adjust it to work the way that you want it to. Now, as a case study, I want to take Flexbox. It's been, 7 years or more since it was first seriously proposed as a feature. The specification still isn't stable. We're approaching interoperability across browsers, but we're not quite there yet, I think. We know that there are cases that Flexbox doesn't work for. We know that there are ways that people would rather it work, that because it was built into the spec early and everyone went and implemented that way, we can't change it now. Right? So if you look at Flexbox, it's an exemplar of the old model. Really, really, really long time periods before things become available. An even longer road to full interoperability, and no way to adjust the feature once it's brought out. If we had built Flexbox on top of Houdini, then you could imagine things feeling a lot more agile. We would have lots of early versions of Flexbox built by lots of different CSS or web authors early on. People would play with those libraries. They'd make changes. They'd make suggestions. People would gradually coalesce on a unified version that everybody wanted to use. And then, if that was popular enough, we could take that and we could enshrine that in a spec and build it as a primary feature. So we've just said Houdini is extensible CSS. But there's other ways to think of Houdini as well. So Houdini is also access to the layout and paint stack. If you think about a modern web browser, the main way, if not the only way that you have to affect the pixels that people see is by changing the DOM and changing your style sheets. Right? You do that, then an engine comes along and it computes styles for all of your elements, and another engine comes along and lays those elements out, and then another engine comes along and paints them to the screen. And you have no access anywhere to any of that process. So Houdini opens up the ability for you to get in and change layout and change paint to work the way that you want them to. And another way to think about Houdini is that it's custom elements, but for style. So we all know that custom elements are a feature that lets you go beyond what HTML5 provides. You can say, I don't want just this fixed set of elements. I want to go and build my own elements that do do things the way I want them to do. So if you imagine a similar idea, a similar ability, but for style features instead of for elements, that's another way of looking at Houdini. So as you listen to this talk, keep in mind that each of the APIs that we talk about, they both solve an immediate problem. They both take a use case and provide an API to solve that use case, right? But at the same time, they also contribute towards the greater goal of extensible CSS. And the intention or the impression that I want to give you here is that the whole is greater than the sum of the parts. That together, all of these APIs combine and form something which is much more powerful than you can do with each API individually. I'm going to give you a rough overview of the current specification state for Houdini. I'm then going to give you a very, very brief overview of implementation state. After that, Eddy's going to talk about the typed.om, which is one of the specs. And then Ian is going to take us through the layout, paint, and compositor worker specs in a little bit of detail as well. And I promise there'll be demos. Well, videos. Demos, yep. So all the specs are written in the Houdini task force. This is a combined task force composed of the CSS working group and the technical advisory group at the W3C. We do incubate some new specs through the WICG first. Most of the specs are available at this link, so if you go there, you can sort of see what's there at the moment. We're on GitHub. So these links provide access to some of the GitHub sites that we use. We use GitHub for specification drafting, we use it for issue tracking, and we might even shortly in the future start using it for polyfills of some of these features as well. We really strongly welcome non-member contributions. This is really, really important. So if you have use cases for things that you think Houdini should be able to do, jump on and file issues. If you want to discuss some of the features that we're already talking about implementing, again, jump on, contribute to the issues, join the discussion. And we even welcome specification edits if you are that way inclined. If you want to submit pull requests, we definitely consider pull requests from non-members as well. So, come be part of the discussion. We'd really welcome a wider audience looking at these specs. So a brief specification roll call. We have 4 specs that are ready for experimental implementation. And just starting at the bottom with the Paint API, this is do-it-yourself rendering. This is the ability for you to get in and change the way that things are painted. And the Paint API is based on the typed.om, which is high-performance object access to the CSS.om, properties and values, which is like the existing custom properties in CSS, but with types associated, and worklets, which is a way of providing synchronous, isolated JavaScript execution contexts. So these 4 specs are ready right now for people to go and start experimenting with implementations in different browsers. We have 3 specs that have a pretty good degree of forward progress. We have the Layout API, which is like custom paint, but for layout. We have a font metrics collection of APIs, which give you programmatic access to different parts of the font information. And we've already started talking about what might go in level 2 of the Paint API. So this is do-it-yourself rendering, but better. Thanks, Sam. We also have 2 areas of investigation underway. These are quite different to each other. So scrolling, we've done a lot of talking about extensible scrolling. There's lots of different ideas at play here. There's things like compositor worker, scroll customization, declarative scroll linked animations, and lots more ideas. It's a very complicated area. We don't know yet what the right approach is, so we're trying to explore all of the different approaches and come to some gradual consensus with different browser vendors. On the other hand, parsing, we haven't really looked in detail in parsing. We know that at some point we want to allow people to extend or even replace CSS syntax. And as we do more investigation, we'll know what the right way to do that is. These are both happening through the WICG at the moment. Now, very briefly, implementation status. So in Blink, we have partial experimental implementations of the typed.om, worklets, and the Paint API, and we'll show off the typed.om and Paint API implementations to you very shortly. And we intend to start working on properties and values soon. We also have an experimental implementation of compositor worklet, which we'll show off too. And this last one's really important. A shout out to Firefox, who's actually begun implementation of properties and values. And it's likely that they will beat us to it. So that's really exciting that, that we're seeing lots of different vendors start to look at this stuff. And with that, I'll hand over to Eddy.
Cool. Hello, everyone. I'm going to show you a few examples of what we're trying to solve with the typed.om. So the typed.om is a drop-in alternative to the current string-based JavaScript API to the style engine. So, okay, wrong way. In this example, I'm trying to create a box shadow that has the same color over lots of different elements. And to do this, I have to build up a string that has the R, G, and B numbers that I want in lots of different places. Then what I'm going to do is I'm going to pass that into the style engine, which is then going to parse it immediately. The same thing goes for my transform example here. You have to do the scale value, the rotation value, translate value, etc. And so in the type to Whim, I've actually implemented this already. You can try it out on Chrome Canary if you enable the blink flag CSS type to Whim. And in this example, I just took the transform one, and I've put in the scale, the rotation, and the translation. And so don't build any more strings. Yay! So the second problem that I'm trying to solve with this is parsing strings. So if I want to get out of the style engine what the transform currently is, I get out this sort of opaque string, and then I have to maybe use some library to parse it if I want to figure out how many degrees was that rotation. And then to update it, again, I'm going to build a string, and then I'm going to put it back into the style engine, which is then going to parse it, which is slow and awful, and let's not do that. So don't parse strings. I can get my transform value out of my element, and then get the components out using the new iteration syntax, and then update the second component, and then pass it back into the transform value and set it into the element. So no more parsing strings, no more building strings. Yay! So I have a couple of demos up on my GitHub if you would like to check them out. They're based very heavily on the GSAP Starfield demo. Then I also have a video demo of what I was just showing you in my examples. So this is actually using a content shell that I built on my own computer, and there's an element here that it doesn't yet have a height, so you can't see it. So what I'll set is the height, hopefully. There we go. And then that works, and you get in the Google logo because it's got the height and the width. Now, next, I'm going to build a list of transform components. So the first one, if I remember correctly, I've added the rotation. So I'm going to rotate by 20 degrees. Then I'm going to set that straight into the style map for the transform, and there it goes, it rotates. And then I decided I also wanted to scale my element, so I've added to the same list of components a scale object, and then set that into the transform value. And so this is really great. If I wanted to update it, I didn't have to go and build a bigger string and put it in. I just added another object and put it back in. Cool, and with that, I'm going to pass this off to Ian to talk about the layout API.
Cool. Hi, how's it going? Hey, how's it going? Great. So layout API, what we want authors to be able to do is, as again with the Flexbox example before, unleash a whole bunch of new layouts on the web. So explicitly enable, constraint-based layouts are really popular on native frameworks. Be able to build in userland, a really good polyfill of MathML. Be able to do Nuth plus line layout if you really want to. A whole bunch of these, layouts just aren't possible on the web today. Oops, there we are. Same bug, user error. If you want to know more about the layout API, hit up this link here. This contains basically a very rough draft of the direction that we're heading with it. It's got all sorts of good stuff like fragments, constraint spaces, break tokens. I'm going to do a run through of this API tomorrow afternoon in the CSS Houdini layout API session. Anyone that's interested in layout should go to this talk. It should be a lot of fun. We might have to tweak our layout engine slightly to support this layout API, but it's going to be a lot of fun. The next API that isn't Vaporware is the Paint API. And what this allows you to do is anywhere that you can put a CSS image value, so things like background image, border image, content, for example, you can add a Paint API image. So what the actual API looks like is this. You register a custom painter, so in this case, circle, because it paints a circle. and then you give it a custom paint class. The first thing that you do for every custom painter is you give it a list of input properties. These are things that when the value of this property changes, so this could be a native property or a custom property as well, we need to paint, we need to paint this element again if it's visible on screen. So in this case, we're going to change, need to repaint any time that the circle color property changes. When that happens, the engine will explicitly call into the paint callback where we give it a paint rendering context, the geometry, so the size of the element, and then the property map containing all of the properties that you listed. So here, first thing that we do is we grab the circle color, set it to the fill style of the paint rendering context, do a little bit of math to work out where to actually draw the circle, and then finally just paint the circle. So that's pretty boring. Here's an example where we actually, can we hit play on that? Where we actually draw a speech bubble, for example. So you can see here, we've just got hooked up Sam's lovely color picker. You can see here that the width of the element is 200 by 100. So we've set the fill color to a navy blue, for example. First thing that we're going to do is add a radius to that chat bubble. So you can see here we've gone from 10, 20, 30. That's all, we could have just done that with border radius for now. The next thing that I'm going to do is add a caret. So you can see that's where the speech is coming from. We can alter the size of that little caret there, so it goes from 20 to 30, hopefully. Oh, hey, there we are, 30. And then we can change the offset. So it's, we're just moving it along so that it's positioned on the right-hand side instead of the left-hand side. You could imagine a more advanced API where it can appear on the top, side, wherever you want. The final little thing that we're going to do, it might not show up here, but we're adding a very subtle shadow to this. And then because I'm OCD, I'm changing it back to the initial color. One of the coolest things here is that you can see that we're actually painting outside of the bounds of the element. So, we're not just constrained to just painting inside of the 200 by 100 rect. We can actually paint a little bit outside of it as well. This is possible because we're using border image down here. The next really cool, I need to do this manually. Next really fun demo that we've got is a QR code. Who doesn't like QR codes? Yeah. So you can see here that the QR code always paints in the middle of the element. So, there's no having to add an additional element and then, display flex the parent element and get to a line in the middle. We can just directly paint, I can do maths. I'm just going to add it into the middle of the element. So the first custom property that we've got here is QREarl, which as you, change it in DevTools, it progressively, adds it. I'm just going nuts here. The QR code gets denser and denser. And now I try and backspace out of it and then realize that's a silly idea. The next property that we've got is QR color, and this is, just changes the color of the QR code. So here we add it as an awful green, and again, we use Sam's awesome color picker. Yay, Sam! This has made my life so happy. To change it to a lovely navy grayish blue or whatever again. But this shows you, the real power of the Paint API is that with very, very simple properties, you can, achieve really, really, cool effects. One thing I didn't mention with the, can we go back one slide? With the speech bubble demo. There we are. One thing I didn't mention with the speech bubble demo is you can see subtly here that, there's nice little angles between the actual caret and the actual speech bubble. Traditionally, how you'd do this on the web is you'd add a pseudo element before or after, and then you'll do a nasty border thing to achieve the triangle, and you wouldn't get this nice smooth curvature between the actual content and the actual after element, for example. So this allows you, the Paint API just has so much more powerful than trying to do this with DOM elements and building up CSS that way. So what's coming soon with the Paint API is you'll be able to declare using the custom properties and value specifications that particular properties actually have types. So you'll be able to say that double-image is of type of an image. So you can say, this is going to be an URL referencing to some PNG. And then you'll be able to explicitly draw this directly into your canvas at paint time. Same thing with filters. You'll be able to build up very, very complex filters in CSS and directly set this on the paint rendering context. And same with fonts. You'll be able to say, you know, I want you to use this particular font face, and you'll be able to set that directly into the paint rendering context font, and then subsequently draw text. So this is, the images especially is going to be very, very powerful for composing things. So you could imagine that you want to draw, you know, like a Hangout style, you know, bubbles of all of the people in your chat. You could have a list of images for all the different people that are in that chat, and then just paint all of the circles for all of the people in that group chat, for example. Instead of having to build up a large amount of DOM elements to get the effect with CSS and DOM that you want. So this stuff is really exciting. Next one I'm just going to quickly demo is the compositor worklet. As of this morning, I think this is all main on trunk at the moment. What this demo shows us is with compositor worklet, you can link touch events to actual transform opacity style changes. So you can see in this demo that, you know, we've got a fling effect, scrolling effect that's directly changing the profile thing on the compositor thread, and also fading in and out the header bar there. If you've got something running on your main thread, like a janky script, you know, you're doing lots of JSON or XML parsing on your main thread, this is still going to respond smoothly with your touch input. So this is a really powerful feature that we can expose to the web platform as well. If you want to know more about that, talk to Ian Volek and Rob Flacker. Oh, there we are. So finally, covert is something that Shane and Doug quickly worked on for 3 days, which is sort of bringing a lot of these APIs together. Covert was an attempt at emulating some of the SVG API at a user level instead of at the browser level. So it uses custom elements, a bunch of the Houdini APIs. You can see a sample of the code here, for example. So we've got something similar to your SVG repeat, drawing a circle. We've got a texture here as well. And you can see actually draws real output as well. This, I think, was about 500 lines of code, around about that. So with these very, very powerful platform features, with a little bit of JavaScript, you can create incredible polyfills for platform level features that are relatively high level. If you're interested in that, there's going to be a breakout session planned tomorrow afternoon as well. So finally, we just wanted to quickly talk about one more thing that we're spending a lot of time thinking about as the web platform team at the moment, and that's being able to time slice a lot more work through web APIs. We sort of just bookended this on the end of this talk just because we thought it was really, really important to talk about. So an example of what do I mean by time slicing? So there are a lot of APIs on the web today that aren't sort of respectful of the main thread. So one is in a HTML, or just appending an element. In a HTML especially, you've got to pass all of your HTML. You've got to then recalc style for a layout. If you suddenly do a read right after you append all of that HTML. With async append, it's possible to actually time slice this out over multiple frames. So your critical user gesture here doesn't have to wait 3 or 4 frames instead of when it could be played here. So it's really about respecting the main thread quite a lot. Excuse me, I've got a dry voice. The other example of sort of respecting the main thread is being able to be able to perform tasks either on the main thread or on background thread. So we're sort of thinking about task worklets a little bit. So what's the sort of nicer API for workers that could potentially run on the main thread, and we've got a bunch of performance optimizations that we could do there, or run on a background thread if needed. So you can see here that if you've got lots of tasks that explicitly just set timeout 0 or something like that, they're bunched up on the main thread, potentially blocking a whole bunch of user input. Here we could potentially time share between a background thread if we need to, or actually perform them on the main thread when we've got time. You can sort of think of this as like workers plus request idle frame. But there's a bunch of things in this sort of area that we're thinking of as sort of, async append, task worklets, resize observer, so actually delivering resizer changes when you actually need them on the main thread, batching DOM read writing, things like giving you hooks to know when a script is compiled correctly. It's really about time slicing a lot more of the APIs on the main thread and just treating it with a little bit more respect API-wise. So with that, we hope that you're excited about these APIs as we are. If you are, Elliot's excited. If you want to get involved, talk to us in person. Reach out on the GitHub issue, file feature requests if you want them. With that, are there any questions? Yes. Oh, Mike. Do we have a mic? Huh? I can repeat the question. Sure, go for it.
So is there any hope of implementing the whole SVG spec in terms of Houdini?
So the question was, is there any hope of implementing the entire SVG specification in terms of Houdini? Yeah, I think so. I can't say for sure. The SVG spec is huge. I've found a couple of things which we already knew we were going to build that will make things, make that task easier, and a couple of things that we didn't yet realize we needed to build that I'm going to start proposing. But yeah, there's a good chance.
Is the entire CSS, I guess, spec exposed by type.m yet?
Not yet. I've done most of the very simple types. So numbers and lengths and transforms, because they make a nice demo. The rest of them are coming. I'm also waiting on some spec stuff.
Well,
Yes.
yeah, so
Before,
in spec terms,
yes.
we decided to decide on an MVP of types for level 1 rather than trying to spec all of CSS. So in level 1 of the spec and in our first release, you won't have access to everything. Those things which we don't have explicit types for, you'll fall back to just a plain star value, which will have the CSS text available. So you can still use the star map for those things, and your code will continue to work as we add more.
Out of curiosity, do you know how fast Story is using OEM instead of doing the string concat and the old style CSS?
We haven't done a lot of performance testing on it yet. Our initial things on using transforms is that it's not faster, so I'll need to look into that.
But it definitely, we expect that there should be
Yeah.
performance gains there.
I've been focusing on just making the things work for now, so probably I've done something bad, but I will fix that.
Thanks.
We're not slower yet, which is good.
As an example, like I think with the anemometer benchmark, there's a few benchmarks there where we are just completely style bound, just because it's setting transform strings, then we have to go and pass the whole string. There's a bunch of work that we can fix in the parser there, but it would be great if we could just skip the parser entirely. So we should see large performance in those types of benchmarks.
Other questions?
Mike. Give Mike a mic. That never gets old. No.
Just to follow up on that previous point you made about anemometer and the benchmarks, would that require changing the benchmark to use the CSSOM to get that speed improvement?
Yeah. You have to use the new API to try and test how fast it is.
Yep, and I think that's a totally legit thing to do.
You're just doing it, so I need to run front, back, front, back. Yes, but only one micro is running around.
When can we have it?
Which part?
It's awesome. By
Which
the way,
part would you like?
everything about this is amazing. God, I can't decide. I want it all. When can we have it?
So I guess there's experimentally you can have it now, right? I mean,
Yeah, I mean, some of the stuff is on Chrome Canary just behind a flag for Type2M.
we could definitely consider doing Origin trial. That'd be really interesting. The other thing is that the four RecTrack specs that I mentioned up front have now been published as FPWDs. Yay! So yeah, we could start to look at a release schedule, I think.
Yeah. I think it's probably not unreasonable sometime in Q3 to have parts of it.
I mean, that'd be super exciting.
Yeah.
Which year?
Which hemisphere? Yeah. Elliot. Oh,
Elliot,
behind you.
that's a
Yep.
question.
Does this work with transitions and animations?
Not yet. If you're talking about Type2M, not yet.
The other thing is with properties and values. Sorry.
Well, I mean, there's no reason why the Type2M won't work
Oh,
with
well-
transitions and animations. The piece that we're waiting on is properties and values. Once we get that working, then yes, this will work. This integrates very, very cleanly with transitions and animations. Once you can say, you know, such and such a custom property has type length, then we know how to animate that. So when you put into your CSS transition that you want to change that, right? So your example of the speech bubble, you could animate any of those properties smoothly once we have the properties and values API. Actually, I think that is basically one of the main reasons for the properties and values API.
Cool. Fantastic.
Thanks, everyone.
Thanks you very much.